the command line. All right, perfect. There we go. So again, you can do pretty much anything that you do regularly on your computer, like dragging and dropping files, opening the internet, not so much. Well, yes and no. That gets complicated. Topic for like 2 months from now. But most basic things you can do on your computer, you can do through the command line. And that's why today's lecture is going to be about the foundations of how to do basic stuff with your computer. So what can we do to the command line or with the command line? There's a lot of essential things that the command line can do for us, but we're going to talk about the easiest to use features and the ones that I just like using. So the first one is you can add and remove folders, and you can also add and remove files. Now, why is this helpful? I mean, I'm sure all of you guys know this, but if you have, I'm sure everyone's seen like someone's desktop that has like 100 files on it, and there's just like file, 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 and you can't see anything or make head or tail of where to go or where to find something. It's kind of like a really messy closet. Versus you have a desktop that has a folder and then a nested folder within it, and then another folder, and they're all nicely labeled. It's the same sort of thing as putting boxes and organizers in your closet. It helps you find things, it looks better, and it just makes you a better person. So that's where adding and removing, adding folders and adding files come in handy in a very basic and easy to do way in the command line. You can also list content. So if you're in a folder and you want to see what's in this folder, well, this will tell you, you'll be able to find out what's in it. And you can also jump around between folders, because what's the point of staying in a folder if you can't move around to other ones? So there's a few functions, or I guess not necessarily functions, but code keywords slash actions that one has to type into the terminal in order to do the things that we talked about. So if we go back to that graphic of the graphical user interface versus the command line interface, the graphical user interface looks nice. There's many different ways to customize it. Command line, no. It is words and more words on a very boring background. So if you want to create a folder like on your desktop, what would you do? You'd right click and then go to the little drop down and then click create new folder, and then you can type in the name and maybe add a color or like move the position. No. Command line, nothing like that. And we're going to see that shortly. You type in a command, you type in the name of the folder, you hit enter, and it creates it. In what order and what color, none of that matters. You say create a folder and it creates a folder. You tell it to create a text file and it creates a text file. Super bare bones. And that's the nice thing about the command line. It's very no frills. So if something gets messed up or you realize you made an error, it's not too hard to backtrack. In general, for the simplest tasks. Also, generally, if people say that something is very easy or very hard in computer science speak, there are a lot of asterisks and caveats on all of those statements. As an instructor, I always do my best to try to present those, but sometimes I forget. So if I end up saying, oh yeah, this should be a really easy task that nothing ever goes wrong with, please do not believe that and be like, where does it go wrong? Or I'm going to find a way to make it go wrong, which is also very valid and one of the things that we're going to be teaching you guys to do as well. Anyway, so these are the main actions that you guys will need to know for the command line. You have mkdir, or make directory. You have touch, which creates your file. You have rmdir, which removes a folder, but it only removes a folder that's empty, aka a folder that has nothing in it. Meanwhile, rm with a space and then -rf removes everything in that folder, and then also removes the folder. So it's kind of like the equivalent of deleting the folder or tossing in the recycle bin. rm removes a file. ls basically is a list command. And then cd lets you change directory. So we're not going to do this exercise right now, but what we are going to do is we're going to go into my command line and play around with this. So one thing to note, I use Windows, and because of that, I'm going to be doing everything in WSL, or the Windows shell for Linux. This should look similar in syntax to most of the stuff that the Mac users and the Linux users will see on their screen. However, certain key functions may be different, especially between Windows and Mac. So if you guys see something that you're like, I don't know why his screen looks different, it's probably because of the Windows versus Mac difference. Now, the good thing is some of our other instructors do use Macs. So on those days, the Mac folks or the Windows users in the class may be slightly confused. It's part of the fun. And also, in the professional dev environment, the good thing is a lot of places still rely very heavily on Windows and Linux. But there's also a lot of companies that are transitioning to Macs and have been for the past like 5 to 10 years. So even if you're not coding on Windows or coding on a Mac or coding on a pure Unix machine, it's still helpful to see what that looks like from the other side. And this class is one of the best ways to do it. All right. So anyway, that's my little ramble about why watching lecture is good. So pay attention. All right. So also, I recently just had to wipe my hard drive a while ago. So thankfully, my computer's okay. But the good thing about that is I had to install a brand new installation of WSL. So my desktop in WSL should look pretty similar to everyone else's. So the first thing I want to do is make sure that my desktop has stuff on it. So I can type ls, which lists all the files in my folder. And it didn't return anything. Did my code glitch? No. This is a brand new installation, so I don't have anything listed in my in Linux. So that makes sense. Now, what I can do though is I can add some things to play around. So let's say I want to create a folder. We're going to call this my folder. Okay, I don't know if it worked or not. How can I check if adding a folder worked? Well, we'll just go back to listing all the files. If we can, if we were able to successfully create a folder, it should show up in our list of things that exist in your home directory. And we see now when I type ls, my folder does indeed show up there. So that's good. Now, let's say that I wanted to create, I don't know. Let's say I wanted to create a text file. So we can create a text file. Let's call it text1.txt. And again, we don't get a confirmation that the file was created. You'll usually, the general thing for the command line is if something was successful, you may not see something show up. If something failed, you will in general see an error message. Now, the good thing is, if nothing showed up, that usually means it's okay. But to verify that, we're once again going to hit the list command and make sure my folder is still there and my text file is still there. All right, nice and easy. So now, close out this. Let's say that I want to type something in my text file. How can I do that? Well, the easiest way to do it is by opening it up in VS Code. Now, what we could do if we were boring people was open VS Code, hit open file, navigate to the file, and open it that way. But that's complicated and also boring. Instead, we can just type a very simple command to do this. You type code, which should automatically open VS Code, and then the title of your file. And we'll give it a second. And here, I'll switch windows. And you can see that it opened up text1.txt in my VS Code window, which is pretty handy. So if I'm, in a very convoluted project that has like 15 different folders, 5 different subtrees, and like 100 files, I might not want to go, to open a file by, going through and typing, the individual directory and folder tree. If I already have it open in my terminal, I can just navigate there by just typing code and then typing in the name of the file. Super simple, super easy. And then of course we can change things. We can say hello world. This is my first file. Blah, blah, blah. Right? We can type whatever we want to in here, and then you can save your changes, and then we can close out. So let's go back to the terminal and let's change some stuff. So let's say, all right, I edited this text file, great, but I don't like this text file anymore and I want to delete it. Well, we can remove the text file by saying remove text1.txt. And how do we check that it's removed? We go back to listing all the files, and we see now that we had our folder, then we created the text file, which showed up here, then we removed the text file, so now it doesn't show up anymore. The ls command is very powerful for just error checking if I'm creating or destroying or renaming a file, did it go through okay? And in this case, it looks like it did. So let's say that we wanted to go into well, let's say that by accident, I forgot that I'd already removed my file. So let's say that I decide to try removing it again. If I do that, you see we get an error. And it says, cannot remove text1.txt, no such file or directory. So that's what I meant when I mentioned earlier that when things are successful, you may not see a message. When you get an error, you generally do see a message. Are there any questions about anything I've talked about before we move on to some of the other functions and features of the command?
I do have a question, but it's not really what you talked about. So when you open the terminal, yours is starting with like at the desktop. Mine is not
Yes.
like that.
So that is a quirk of WSL. As long as your terminal shows you a $sign and shows
Yeah.
you some sort of a file path, you should be okay.
Okay.
But basically, this is just saying my username at my computer name. So if my laptop had, say, multiple different users on it, then you could switch the user, and then this would change to whatever the other user's name is, and this would stay the same. But yeah, good point. Does anyone else have?
Yesterday,
Oh, sorry, go ahead.
yesterday I had these colors too. Like now I don't have them.
The colors are
Like
not a big
blue,
deal.
green.
Those, yeah, there are ways to change those. If you go into like the drop down settings, at least on Windows, you can change some of the things like color schemes and profiles and things like that. But we won't do that today. All right. Any other questions before we move on to directories? Okay, let's do some stuff with folders. So whenever I go into a folder or whenever I forget stuff, I always just go and type ls. So that way I know what stuff is in my thing before I start messing around with it. So I created this my folder earlier, right? Let's go check it out. So we can go into a folder by using cd or change directory and then the name of your folder. So also the way you copy paste is kind of weird. You do not use Control or Command C and Control or Command V. Instead, you double click whatever it is you want to copy, you right click on it, and then you right click again in order to paste it. So let's go into my folder. Now we see that the path has changed. Instead of being just a squiggly line, which is basically your home or your uppermost directory, we are now in squiggly line / my folder. So we've successfully entered into my folder. Now let's say that I want to add another folder. Let's say we can say my folder 2. And now we check ls. So because I'm in my folder, I now see all of the files and folders and things that live inside my folder. So my folder 2 is created inside of my folder. Now let's say I wanted to go into my folder 2. Well, we just do the same thing. We say cd into my folder 2. And now we've gone from the home directory to the my folder directory, and from my folder down one more level or inside to my folder 2. Now, let's say that we've gone like 15 folders deep, which is pretty easy to do, especially for big projects. And let's say that we wanted to backtrack. So to backtrack, I think Megan just alluded to this in the chat. You use cd dot dot. But importantly, in general, you want to put a space between cd and the dot dot. You can do cd dot dot on some operating systems, but most of the time it'll show you that the command is not found. So if you have multiple commands in one, or multiple things for a command in one line, you generally would like to use spaces. Oh, I just paused my screen share by accident, and let me mute those notifications. So, and yes, so PWD can also be used to find your working directory. So this is my working directory I'm in right now, which is short formed over here, but I'm in home, and then UA which is my username, and then I'm in my folder. So that helps to show you where you are. All right, so yep, all good. So let's backtrack one more step. We'll go back up to my home directory, and we are back up to my folder. So let's say I want to try to delete my folder. Well, the easy way to do it is remove directory, my folder. However, it's saying the directory is not empty. But did I ever put anything in my directory? Why might we get this error saying the directory is not empty? Anyone have ideas?
I would just guess because typically you would have something in it, so it's kind of to protect you.
Okay,
You create a folder inside a folder. So there's a folder in it. Is that why?
maybe, but let's check. Yeah, so well, how do we check what's in the folder? ls, perfect. Yep. So what we're gonna do is first we need to change directory and go into that folder again. We're now in that folder, and now we're gonna do an us, and aha, we do have a folder inside there. It's my folder 2. So let's go back out. And now we know that it's full directory, so we can't just remove it normal. Instead, what we can do is use the recursive remove, or rm space -rf, my folder, which removes not just the folder, but everything in it. And we see we don't get an error message this time. And if I type ls, my folder has disappeared. Any questions about the difference between those two functions, about rmdir and rm-rf? Okay, awesome. So now let's see. So we talked about changing directories. We talked about opening code. We talked about creating files. We talked about removing files. We talked about removing folders. And we talked about the not funness of seeing errors, but also the helpfulness of creating errors. The helpfulness that sometimes happens when you see errors. Most of the time, command line errors are relatively easy to read for things like this. Sometimes they may not be. And that's okay, and that's a skill that we will build up to. But in general, when you see an error, don't start panicking and thinking that like things have gone terribly wrong. Usually, take a step back, look at the error, and diagnose what it says. Now, for example, if we look at the rmdir error we had here, It's very easy to say, oh my goodness, maybe there was a typo, something else. Nope. All it says is the operation failed in my folder. Why? Because it wasn't empty. Then we checked that it wasn't empty, and it turned out it actually wasn't empty. So then we use the recursive, well, we know the folder is not empty, so we're going to remove it anyway function. Reading the error messages is absolutely critical to doing good code. All right, so now that ramble's over. So here, let me just make sure that everything's blank. Also, this terminal has like 20 odd commands in it now. It looks ugly because there's so many commands in it, and I don't want to see any of this. In order to not see anything anymore, you can type clear, and it just clears the whole terminal. Super nice, simple, cleans up what you're looking at. So if you're, say, jumping from one exercise to another, or one coding set to another, you can always type clear, and it should do that. Also, you can always open up multiple terminals at once, which you will end up doing at some point. I always found it's very helpful to do that. If you're working on multiple different things, but that's another lecture for another time. So we're going to move on to the second thing for tonight, which is Git and GitHub. So you all have GitHub accounts, but we're going to talk a little bit about what Git is. So Git is essentially a software for version control. So think about it sort of like a Google Doc. So it's a way for you to track your changes. It's a way for you to send your code to other people. It's a way for them to make changes. And it's a way for you to track the history of what you've done. Now, this does not have anything to do with like people typing at the same time and stuff like in Google Docs. So forget that part. Everything else is mostly true. So GitHub uses these things called repos or repositories, which are basically folders that are version tracked. The way that we create a folder for this sort of thing is by doing a git init. You're saying git initialize my first repository. So don't worry about the errors right now, or the hints, I guess. So also hints are usually shown in yellow, errors are shown in white or red. But what it says is it initialize an empty Git repository in this folder. So usually repositories have something called a master branch, which is like the version 1.0. And then you can add other branches for other versions. So let's say that, you're plodding along, you're working on your code, and then you're like, ooh, I need to create an experimental fix or like a beta version. That would be an example of a branch where it's a variant of the code that's in your master. It may sound a little bit confusing. It gets easier when you guys try some examples that will be there in the homework this evening. So we've created our Git repository. Well, let's see what this looks like. So I'll go to ls. I see my first repo exists. Okay. Let's change directory to my first repo. And that's a folder. Okay. And there's nothing inside it. Okay. Interesting. So let's see. What do we want to do? We can create a piece of code. So let's say we're going to create text1.txt. Oh. No, actually, let's see if that, I don't think that this would have done it. Okay, that did not do what I wanted it to do because I typed the wrong function. What I meant to do was type touch text1.txt. So we've created a text file now inside of our repository, and now we can say code text1.txt in order to open it up in VS Code. So I'm going to switch over to my VS Code window. And let's see, what does it say? A Git repository. Just to open the repository. Sure. Just do that for now. Don't save that. And we have opened up our text file. So let's say this is my first repository. I have created a text file to document this. So we've saved our text file. Okay. Oh, let me go back to Here, so I created my text file, I've edited a little bit, and sorry, I've created my text file, I've edited it, and I've saved it. Okay, great. Now what? Well, let's say I want to check what I've let's say I make a bunch of other changes in other files too. I need a way to say, okay, I have no clue what I just changed. Let me go and check and make sure I didn't change something I wasn't supposed to. We can do that by typing git and then status. And if we do that, we see it's on the master branch, which is good. Don't worry about the commits. But then we see untracked files and it says text1.txt. Now, what does that mean? Essentially, what that means is you've made changes in text1 that have been saved, but those changes have not been added to Git. Because again, Git's entire thing is version tracking. So in order to let Git know, hey, I changed this file, I want you to know that I changed this file on this date at this time, we need to track the change. And the way we can do that is, as it says on the screen, to do a git add. So let's do that. Let's say git add text1.txt. And now, if we go back to git status, we see here that it says, I created a new file called text1.txt. Now, we can unsave changes and things like that, but I won't talk about that tonight because that's not what you guys need to know. But basically, let's say that you realize, oh, I actually didn't want to change that file. It's pretty easy to backtrack by using git rm cached. But again, different topic for another time. So, all right, I've now told Git that I want to I've created this file. Okay, that's awesome. I want you to track the file. Okay, but it's still not tracking the file. Or more specifically, it's tracking that the file has been changed, but let's say I want to like permanently save my file as like this is the file. This is like the version that's gonna go onto the internet forever. In order to do that, I need to do something called a git commit. As it says, changes to be committed. So we're gonna say git commit, which basically says all the changes I've made, I'm signing off on them. They're good. We're gonna push those changes up. And whenever you commit, you want to write a message. You use -m for that. So what we're going to say is all file changes good, or, something like that. And then it tells you exactly what happened. So it says, I changed one file, which was text1.txt, and I added 2 lines, which that's accurate. That's what I did. I added a line, I hit enter, I added another line. And then it does some things internally to say, yes, I have affirmed that this file has been created and established, and we're good. And now if we do git status one more time, we see here that you're on the master branch, and there's nothing to commit, aka you don't have any untracked changes, and you don't have any unsaved changes. Great. But here's the thing. What we just did is fun and useful on your local machine. Let's say that I want to send Mike my changes, and I want him to be able to see them and review them. Right now, he has no way of being able to do that because Git is located on my local machine. The way that we can do that is by using GitHub, which is, again, the thing that our curriculum is located on, the thing you guys all created accounts for. And what we can do there is we can push our local changes up to GitHub. So to do that, first thing you need to do is create a GitHub repository. So go back here and, oh, wrong window. Let's see if we can find command line. Oh dear, I do have a good number of windows open. Here, we'll just do share screen. So I've created a blank repository here, or I've created, let's see. Actually, we'll just go ahead and create a blank repository right now. We go to repositories, and you look on the right, and we say, we'll just delete Okay, we'll delete that later. Go to new, and let's just say my repo 1, creating a brand new repository, and I own this. It's public. And I now have made a repository called my repo 1 that's public to anyone on the internet. However, if we refresh this thing, well, disregarding all of the stuff that we see here, the repository itself is blank. It doesn't have anything in it. So let's push some stuff up to it. So if we go back to here, I want to push up my text1.txt to this GitHub repository so that Mike or Kim or anyone else who wants to access it can do so. The way we do that is a little bit complicated. The first thing that we need to do is we need to add the repo as a remote option to our console. And we do that by typing git remote. Oh, sorry, git remote, and then add, my mistake. And then we're going to say what name we are assigning to our repo. We're going to call this my repo 1. And then on top of that, we need to put the link to the repository, which again, you do by right-clicking. So we hit enter. It looks like it's been added. We'll just go to git status to make sure nothing was messed up. Doesn't look like anything was messed up. Then the next thing that we do is we're going to do a git push. So we're going to push our changes that we committed up to my repo 1. And then we're going to make sure that it pushes to the master branch. I'll talk about why that's important in a few minutes. But just always add origin master to the end. Oh, let's see. Source ref spec. Oh, sorry. Supposed to be origin master goes here. Okay, third time's a charm. Let's just pretend that that didn't happen. There we go. Okay, I think my origin master decided to be a little bit confusing, but disregard that for now. Anyway, when you have a successful git push, let's go through what happens down here. So the first thing it does is it looks at what things you're telling it to push. Now, what are we telling it to push up to that repository? We're telling it to push all of these changes that were made with that commit, which was adding a file, making 2 insertions, and then calling the commit all file changes good. So it's going to compress those objects, it's going to write them, and then it's going to send them to the master branch, and it's going to send them to my new repo. Now, how can I confirm that this actually worked? We can go back to Google Chrome, hit refresh, and take a look at that. We have now successfully sent a file from our local machines up to the internet. And if we look in here, we now see that this is my commit message, all file changes good. We added the text file, and I've written stuff in there, which is pretty helpful. So in other words, what we just did allowed us to take something from our computer and put it on the internet in one of the simplest ways possible, which is using GitHub. Are there any questions about what we just did before we get into a little bit more complication? And then I'll turn you guys loose for some practice.
Yeah, I got a question.
Please.
When you created the remote for that repo, that local repository, I guess, on your local machine, did you just create an upstream to that location from a folder that you had created with a text file in it?
Yep.
So you just gave that upstream a location in your GitHub.
Basically. So the git remote add will essentially create a pathway that you can call whatever you want. So I called it my repo 1. And that's linked to the GitHub web address. So by saying git push, I'm saying send the files that I've staged in my folder in my first repo, stage the files that I've committed in there to whatever the stream I've named is, which is my repo 1. Where does that lead to? that leads to my GitHub page. Any other questions? I know this stuff can be confusing, so feel free to ask away.
I guess I have to piggyback on what Sean did, that my dash repo dash one. Is there a way to, like, say I forgot what I called the stream? Is there a way to go back and see what I did call it? Because it doesn't show up in GitHub, right?
It does not. Well, it doesn't, but I mean, you can always create more remotes. Let me see.
Or maybe it doesn't even matter.
It actually does matter at the end. Let me try something because I haven't checked this in a while. So that is a good question. Let's see. What would the command be? Let's try git. Okay, that does not appear to want to work. Let's try this. Well, anyway, I will look that up and get back to you. But I'm pretty sure there is a way to do it. Actually, let's see if no, that's just branch. Actually,
Well, that did show it. Yeah, that shows it right there.
that does help. So this gets to the thing that we're gonna get to next. But if you type git branch and then -r, that'll show you the different upstreams, you could call them, that you've created and the different branches underneath that. But we'll get to what branches are in a minute. Any other questions? Okay, so we're gonna go to let's see, git remote show origin. That does not appear to have done it, but I'll take a look. I'll take a look after we switch over to homework, and I'll let you guys know because that is a good question. All right, last part of me lecturing, and then you guys get to have fun working on programming in pairs, which is one of my favorite exercises. But we're jumping ahead of ourselves. Let's say for those of you who have played like video games or are involved with product testing, you know that there's always multiple stages to product life cycles and product development. You've got your alpha stage, which is where you release like your minimum viable product. You'll have your beta testing portion, which where you're going to try new features. You'll have your established release, and all that other stuff. It's all great, but where does that come into version control? That's what we're going to do now with branches. So what a branch does is it lets you effectively create a version of whatever thing you've done so far. So, for example, we had that text1 file. Let's say that I want to create oh, okay, I just had 5 alerts go off on my computer at once. Now that's interesting. Let's say that in addition to creating that text1 file, I want to create a new version of my repository where I also create a text2 file. So let's go ahead and check out a new branch. We're going to say git checkout -b, and we're going to call this branch 2 files. So I've now created a brand new branch called 2 files. Well, what does that mean? So if we go back and we hit that git branch -r, well, first off, we see that our main repository is still my repo1, and we're still in the master up there. But if we look down here, you see that my first repo is now switched from master, which is where it was before, to 2 files. So it tells us that there is a distinction between the master branch, which is like the version of this code I know should work, and the 2 files branch that I have just created. Does that make sense? And there's an even easier way to see that, which is with git branch dash A, which shows you essentially all of the branches that exist. So we have the master branch, which I was on, which is why it's white, two files, which is green because I'm on it right now, and then the remote my repo one master, which is what we pushed up to GitHub, which was that master repository. All right, so now I'm on this new branch. So let's go ahead and create a new text file. Anyone remember how to create a text file or how to create a file in the command line?
Touch.
Touch, perfect. Yep, so we're going to say touch text2.txt because this is very original naming that no one's ever used before. And let's go ahead and edit that. Or first, let's make sure it actually got created. We're going to go to ls. All right, we've got a text2, and we're going to go code text2.txt. Just going to pop it open, make a couple quick edits. Once VS Code opens, so we'll go switch over to my VS Code, and I'll say this is a second file on the two files branch. We'll save that. We'll go back to my repo and just make sure that the folder looks as we expect. Remember, these changes are still on my local machine. Now let's do a git status. Let's see what's happened in the interim. All right, so what's git status then? We're now on the two files branch, which is not the master branch. And just like before, we made changes, but we never saved them in Git. So now we need to track those files. So what we're going to say is git add text2.txt should be added. We'll go into our git status again. And now we need to commit it. So now we're going to commit to our new branch. We're going to say git commit -m created two files with an S, two files branch. We've now committed that we've created our branch. However, this is still not uploaded to GitHub. We need to create our branch. Or, I mean, sure, we've created our branch, that's great. But what does that matter if, say, Sean or Allison can't access it on GitHub? It's kind of useless. So that's the part that we are going to do now. So we're going to do a git push, but before we were pushing from the master branch to the master branch. Now I want to push not from the master branch, but I want to push from my two files branch to a brand new branch that I created. We're going to say -u origin. And now I'm going to specify what branch I want to do this to. We can call this, let's say, branch 1. Hit enter. And it gives an error. Branch 1 does not match any, failed to push some refs to origin. All right. I leave this as an exercise to you guys, because you guys are going to be doing exactly this in about 30 minutes. What does this error mean? Why am I getting it? What are some things we could check in order to fix it? How do I debug this error? Anyone have ideas?
Is the error there because the upstream doesn't have that branch?
B?
Have you made
What do
any
you guys?
changes?
So changes in what way?
Um, I'm reading your file.
You called it a different name, right? You called it two files?
I did. Do you think that could that have made a difference?
I'm guessing. I don't know for sure. You called it branch 1.
Let's see. What do you guys think? Let's get some more ideas in here. The fun of debugging is it's a communal endeavor where everyone suffers at the same time. Except me, because I know the answer, but we're pretending that I don't.
I think that she's right because when you push, you are supposed to push the name, I guess, of the repo or whatever it is, the branch. So and you didn't make a branch one, not that I see.
Okay, so let's make sure. So let's type git branch dash A, right, which we already saw before, lists all the branches that we have. They have our master branch, our two files branch, and then this remote one. So presumably, if you guys are right, if I change branch one to two files and hit enter, this hypothetically should work, because two files has already been named as a branch. Interesting. We now get another error.
What is dash U?
So dash U just sort of it's used as a specification. So we'll get into this in more detail probably later this week. But it basically specifies something and as an input to the git push command. Or more specifically, it's also, I think, a shortcut for set the upstream, if I remember correctly.
Do you have to put master instead of origin?
We could, but that would most likely override it. So that would override the master that we have right now.
Did you ever check out the master?
We did back when we created it.
Did you pull anything?
Nope, didn't do any pulls.
So it's
Here,
a
I mean, we can
mismatch.
scroll up.
You're mismatched from current to what's on the repo on the original, correct?
Could be.
That's my guess. I would try pulling and trying and then re-adding.
Okay. Anyone else have ideas? Remember, they don't have to be right. They can just be ideas. That's the fun of the debugging process.
Is it because maybe you don't have a remote repository for two files? You only have a remote repository for master?
That might be it. So let's try something. Let's try to specify where we want to push it from, which is two files, and where we want to push it to, which is this remote branch that we want to create. So also, instead of retyping the whole command, you can use the up and down arrows in order to go between commands that you typed back in your history. So right now there's nothing. When I do the up arrow, it goes one command up, two commands, one command down, because I hit the down arrow, etc. So that's a useful shortcut that can save you a lot of time. So let's try saying that we're going to push from the two files local branch to, let's say that this is going to be a new branch. That format should work in theory. Origin does not appear to be a Git repository. Okay. This is a very fun start to the first day of class.